Hello children, this is the first chapter for the number systems for standard 9. So this part I will give you the introduction of the chapter. So you have already learned what are natural numbers, whole numbers, integers, etc. We will just recap those concepts. So natural numbers are numbers starting from 1, 2, 3, 4, etc. up to infinity. And whole number, it is all natural numbers plus you will add 0. So 0 is this, 0 is one added along with natural numbers, you get whole numbers. Now integers. So integers are minus infinity to minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, etc. up to infinity. They are called integers and we represent integers as Z. The Z is equal to. Similarly, for whole numbers, the representation is W, and for natural numbers, we represent it as N. Then comes the rational numbers. So rational numbers also you have learned in standard 8, the numbers which can be expressed in the form of P by Q. This is called rational numbers, where P and Q are integers and Q is not equal to, the denominator should not be equal to 0. When the denominator becomes 0, then it is undefined. So the numbers, all the numbers which can be expressed in the form of P by Q is called rational numbers, and the rational numbers is generally denoted by the letter Q. 0 is a rational number because 0 can be expressed as 0 by 1, and all integers including the whole numbers, natural numbers, all are rational numbers because you can express any integer as 2 by 1, minus 3 as minus 3 by 1. So you are able to express in the form of P by Q, and Q is not equal to 0, therefore it is a rational number. This concept also you have learned in your previous class. There are infinitely many rational numbers between any two rational numbers. We will just do a few problems so that you remember those concepts too. Find 5 rational numbers between 3 by 5 and 11 by 5. So 3 by 5 and 11 by 5, you can say 4 by 5, 5 by 5, 6 by 5, 7 by 5, 8 by 5, 9 by 5, 10 by 5. All these are rational numbers between 3 by 5 and 11 by 5. You can choose any of the 5 rational numbers from these. Now you have find 5 rational numbers between 3 by 5 and 4 by 5. Now, in the previous question it was 3 by 5 and 11 by 5. So you were able to simply write 4 by 5, 5 by 5, etc. But here it is 3 by 5 and 4 by 5. So in this case, now we will make it as equivalent fractions. So 3 by 5 can be written as 3 by 5 into 2 by 2. You are multiplying the numerator and denominator by 2. So the fraction is not, it will not change. So it is 6 by 10. Similarly, 4 by 5 can be written as 4 by 5 into 2 by 2. So this is 8 by 10. So it is now 6 by 10 and 8 by 10. Again, if you see, you will not be able to get 5 rational numbers between 7 by 10. Only one you can write. So here we can multiply by or we can multiply by, instead of this we can multiply this by 10 by 10, and here also 10 by 10. So this will become 30 by 50 and 40 by 50. So see how many numbers you have to find, accordingly you can multiply the numerator denominator with the same number, make it into another equivalent fraction, and then continue. So now you can find 31 by 50, 32 by 50, up till 39 by 50 you can choose any of the 5 rational numbers. Now find 10 rational numbers between minus 5 by 13 and 1 by 13. So here again minus 5 by 13 means minus 4, minus 3, minus 2, minus 1, 0. Only you will get only 5 rational numbers. So again we will multiply by minus 5 by 13. We will multiply by 10. So it will become minus 150 by 130. 1 by 13 into 10 by 10. So it is 10 by 130. So you can choose, you need 10 rational numbers. So from minus 49 by 130, minus 48 by 130, etc., 0, then 1 by 130, 2 by 130, up to 9 by 130. You can choose any of the 10 numbers. Suppose you have to find 100 rational numbers in the same question. You have to simply multiply by here you minus 50 to 10. So you will be roughly getting about 57, 58 numbers only. So we will multiply this as minus 5 by 13 into 100 by 100. Minus 500 by 1300. This is the easiest method I am doing, multiplying by 10 hundreds into 100 by 100 equal to 100 by 1300. So minus 499 by 1300, minus 498 by 1300, etc., 0, then 1 by 1300, 2 by 1300, 199 by 1300. Up to this you can choose any of the 100 numbers. So in this sum you have to find the 50 rational numbers between 2 by 5 and 1 by 10. Here if you see the earlier ones and all, your denominator were same, but here the denominators are not same. So in that case you have to take the LCM of the denominators 5 and 10. So 10. So now you have to convert 2 by 5 to equivalent fraction with 10 as the denominator. So 2 by 5. So if you multiply by 2, your denominator will become 10. So multiply the numerator and denominator by 2. So you will get 4 by 10. So now you have to find numbers between 4 by 10 and 1 by 10. But again, if you need 50 rational numbers, but between 1 and 4 you have 2 and 3 only. So now we will multiply by, so 4 by 10 into 10 by 10. So 40 by 100. And then 1 by 10 into 10 by 10 equal to 10 by 100. Again if you see, you have only between 10 and 40, from 11 to 39 only you can write. So you will not get 50. So here either you can multiply by 2 or with 100. So I am going to multiply by 2. 40 by 100 into 2 by 2. So 80 by 200. This is 10 by 100 is equal to 10 by 100 into 2 by 2. So 20 by 200. So 2 by 5 became 80 by 200 and 1 by 10 became 20 by 200. Now 50 numbers between this will be from 21 by 200, 22 by 200, etc. till 79 by 200. You can write, you can select any 50 numbers. Yeah, you will get. Similar sum only here also. Find 10 rational numbers between 3 by 5 and 2 by 3. So you will take the LCM 15. So 3 by 5 into 3 by 3, and so 3 by 5 is equal to, and 2 by 3 is equal to, we will do this in a much more shorter way. So I explained the previous sum, I explained step by step. Now you can do it with less number of steps. So 2 by 3 into 5 by 5. So your denominator became 15, 15. So it is 9 by 15 and 15 by 15. So 9 by 15 and 15, you will have only 10, 11, 12, 13, 14. 9 by 15 and 10 by 15. So you will not get 10 rational numbers between that. So we will multiply by into 10 by 10, here also into 10 by 10. So this will become 3 into 3, 9 into 10, 90 by 150, and this will become 100 by 150. So here also between numbers 91 to 99 only you can, so you are less of one number. So again you can multiply by, so here itself again multiply by 2 by 2. So 9 between 180 by 300, and this will be 10, 100 by 5 into 10, 5 into 2, 10, 10 into 10, 100 by, again no, I have to multiply by 2 by 2, no, then only you got denominator will become same. So 5 into 2, 10, 10 into 2, 20, 200, 200 by 300. Now you can select any 10 rational numbers. So 181 by 300, 182 by 300, and so on till 199 by 300. Select any 10 numbers. Hope it's clear. Now we will convert the rational number to decimals and we will see whether they are terminating or recurring. So 1 by 2, you can write it as, in decimal form it is 0.5. 4 by 5, it is 0.8. 7 by 4, it is 1.75. So now everywhere it is terminating. So in the first 1 by 2 you have only one decimal place, 0.5. 4 by 5 it is 0.8, only one. In 7 by 4 you have two decimal places. So it is terminating decimal. Now take the example 1 by 7. This is equal to 0.1428. If you do long division and see, you will get this. You can check it for yourself. Then again it will get repeated. So we can write this as 0.14285.7. See here from 142 again it has got repeated. See, this is again it will get repeated. So you can put, when it is getting repeated in a particular pattern, you can put a dash over that, over those numbers. Now 4 by 11, you will get 0.3636, etc. So 36 is getting repeated, so this can be written as 0.36. So when you see a bar on the top of any numbers, that number has to repeat. So here in these two examples, they are non-terminating, but it is recurring. Non-terminating but recurring. You have something like this, 11 by 6. So here it will be 1.83333 is getting repeated. 8 is not getting repeated, only 3 is getting repeated. So it is 1.83. You will put a bar on the top of 3 only, not on 8. If you put 83 bar on 83, then it will be 83, etc. So the number which is getting repeated only, you have to put a bar just on that number only. 8 by 45, it will be 0.17777, etc. So it is 0.17 bar. Another example, 11 by 24. You can get these values using your long division, normal long division. You will get 0.458, then 3333 will get repeated. So here you will put 0.458, 33 so you will put a bar just on the top of 3. So this is also non-terminating but recurring. There is a pattern. In the first, here in this example, after 8, 3 is getting repeated. So you are able to write it like 1.83 bar. So these numbers are actually called rational numbers. Rational numbers are numbers which is either terminating rational numbers, it will either terminate or non-terminating but recurring. So I'll see you again in my next video with questions related to these. So till then, try to understand these concepts and see you soon, and bye for now.